Hello everyone, welcome to Equal To, and this is the third video of this chapter number system, which is the first chapter of class 9 maths. And if you haven't watched the previous two videos yet, please go and watch them before you watch this video, because we're going to just solve the problems of exercise 1.1 in this video, and all the concepts and all the approaches, all the techniques that we have learned so far is in those videos, and we are just going to apply those things here. I'm not going to explain the method itself in this video. So if you watch those videos, it would be very easy for you to grab this answers for these questions. Okay, now we are just going to solve these questions. We have 4 questions in this exercise, and here's the first question. So the first question is 0 a rational number? Can you write it in the form of p divided by q, where q and p are integers and q not equal to 0? Okay, so this is the question. So this is just this second statement, second part of the question is just the definition itself for rational numbers. So don't worry about that. So what they have asked is that, is 0 a rational number? Okay, so we have 0, and as we've seen in the previous videos, any number can be written in the form of the number itself divided by 1, and that is no different for 0 as well. So 0 can also be written in the form of 0 divided by 1, and its value is 0 itself, it doesn't change. So 0 divided by 1 is 0, and it can be expressed in the form of 0 divided by 1. When you are expressing it in the form of 0 divided by 1, we know that the value of p here is 0 and the value of q here is 1, and this 1 is not equal to 0. Obviously q is not equal to 0, and hence it satisfies the condition p divided by q. It can be expressed in the form of p divided by q, and p and q are integers. So 0 is in fact a rational number. Okay, and I hope you remember the symbol for rational number is uppercase q. Okay, so this is the answer to this question. There is not much that you can write as answer. So you just have to write that 0 can be expressed in the form 0 divided by 1, which obviously is 0, and here the value of p is 0, value of q is 1, and since the value of q is 1, it's not equal to 0, and hence 0 is a rational number. So that is all the answer for this question. Okay, now we are moving on to the second question of this exercise. So the second question is, find 6 rational numbers between 3 and 4. So this is something that we have seen in the example problems. So the second example that we saw is very similar to this. Instead of 3 and 4, we had 1 and 2. So that is all the difference. So I hope you remember the methods that we discussed there. So we had 2 methods, right? So the first one being using the formula a plus b divided by 2. So we use the ranges, we find the new rational numbers and use this same formula again and again. So that is the first method. And the second method was multiplying by the number of rational numbers required plus 1. Okay, now in this exercise we have two similar questions to find rational numbers. So for this first question we are going to use the method 1, which is this method, and the second question we will use method 2 to solve. Okay, so in this question we are going to use method 1. Now it's up to your preference to use whichever method you want. I just want you to revise these methods, so I am solving this one with first method, but you can also go with second method, that is no problem. Okay, now the first method, we know that in this case a is equal to 3 and b is equal to 4, right? We know that. Now we are just going to apply this formula here. R1 is equal to a plus b1 divided by 2. So that is 3 plus 4 divided by 2. 3 plus 4 is 7. 7 divided by 2 is one rational number. So I'm just going to write it in this corner of the screen. Okay, so 7 by 2 is one rational number that we have formed. Now we can use this as the new range and find new numbers. Okay, so now let the new range be 7 and 3 divided by 2. So R2 is equal to, I'm sorry, it doesn't seem like an R. Okay, R2 is equal to 3 plus 7 by 2 divided by 2. Okay, so now we are going to take LCM for the numerator, and that would be 2 again. So 2, when taking LCM, you would always multiply the numerator by the LCM, right? So it would be 6 plus 7 divided by 2 and the whole is divided by 2. So 6 plus 7 adds up to 13 and the numerator is 13 divided by 2 and the denominator is 2. Now we have seen that dividing by a number is same as multiplying by its reciprocal, right? So it's just going to be 13 divided by 2 into 1 by 2, that gives you 13 by 4. Now these are things that you have already seen. There is nothing new here. Okay, now if you don't know these methods, please go and watch, but you have, it's probably fine, and we'll just move quickly through the next few numbers, right? So for R3 it would be maybe I'll take 7 by 2 and 4. Okay, 7 by 2 comma 4. So R3 is equal to 7 by 2 plus 4 the whole divided by 2, and I'm just going to go quick through this, so don't worry about it. I know you know to solve this question. Okay, so again the LCM is 2 and the numerator would be 7 plus 8, the entire thing is divided by 2. So 7 plus 8 is 15, 15 divided by 2 into 1 by 2, so the next answer would be 15 divided by 4. Okay, so this is another rational number. Now we can use these numbers to generate more numbers. Okay, now these are rational numbers that we have found so far, right? Now we can use these to generate more rational numbers. Okay, 7 by 2 plus 13 divided by 4 divided by 2. You are just going to apply this formula, this one right here, again and again. Okay, so it's very simple. There is nothing to think here. It's very simple. We are just doing it for practice. Okay, so taking LCM, it would be 14 plus 13 divided by 4 divided by 2. 14 plus 13 would be 27. 27 by 4 into 1 by 2, that would be 27 by 8. So that is one more rational number. And okay, so let me just box this up as well. Okay, now moving on with another pair, 13 divided by 4 plus 15 divided by 4 divided by 2. Now these two are rational numbers. You are going to form new one from this. So it would be 28 divided by 4 into 1 by 2 because of the denominator, and it would be 28 divided by 8. Okay, this is one more rational number. Now we have 5. We are going to find the last one. So let me just take these two numbers, 27 divided by 8 and 28 divided by 8, and they add up to what? 5. You'll get carry over 1, 3 plus 2, another 55. Okay, 55 divided by 8, and that is going to be divided by 2. Okay, that is the formula, and it's 1 by 2, and that would be 55 divided by 16. Okay, now these are the 6 rational numbers within this range: 7 by 2, 13 divided by 4, 15 divided by 4, 27 divided by 8, 28 divided by 8, and 55 divided by 16. Now these are the 6 rational numbers that we have found within the range what? 3 and 4. Okay, so this is the answer to this question. Okay, now these are rational numbers, and for you to check, you can just find the absolute value of that and see if it is in the range 3 and 4. Okay, 7 by 2 would be 3.5, that runs right in the middle, and 4 times 3 is 12, 4 times 4 is 16. So any number between that range would be obviously a rational number. So 13 by 4 and 15 by 4 are obviously rational numbers, and 8 times 3 is 24 and 8 times 4 is 36. So any number between that range would also be a rational number. So 28 and 27 are obviously rational numbers, and similarly for the last number as well. So these 6 numbers are rational numbers between the range 3 and 4. Okay, now we are moving on to the next question, which is very similar to this one, and we are going to solve this using the second method. Okay, method 2. We are going to solve this using method 2. Okay, so what is method 2? We are just going to see the number of rational numbers that is required in the question. So in this question, they have said that you need to find 5 rational numbers. So as we know, if we have to find 5 rational numbers, we have to add 1 to that gives us 6, and we are going to multiply the numerator and denominator of both these numbers by 6. So 6 by 6, that gives you 18 divided by 30, and for the next number 4 by 5 into 6 by 6 gives you 6 4s are 24 divided by 30. I have died in 36. Okay, 30. Okay, now you have a range called 18 divided by 30 and 24 divided by 30. Now if you simplify these numbers, they would come to 3 by 5 and 4 by 5. Okay, but we have just multiplied them by 6, so it's easy for you to extract rational numbers between them. Now you can just start writing 19 divided by 30 is one rational number between that range, 20 divided by 30 and 21 divided by 30, 22 divided by 30, 23 divided by 30, and that is all. Okay, now 24 divided by 30, it doesn't come because that itself is included in the range. So these are the 5 rational numbers between the numbers 3 by 5 and 4 by 5. This is the second method. Okay, now second method is very simple when compared to the first method. It doesn't involve a lot of calculations, it's very simple. So you can go with either of these methods, it's not wrong at all, but just for you to know, we saw the previous method as well. Now moving on to the last question of this exercise. Now in this question, this is very similar to the first example that we saw. Okay, now it's just I hope you remember the definitions for the natural number, whole number, and integers and rational numbers. This is what we saw in the first video of this playlist. So I hope you have seen that and you remember these things. So the first subdivision is that you're going to say true or false, and you're going to state the reasons. Okay, and the first question is that every natural number is a whole number. Is this true? This is obviously true. I think you can say it by yourself, but obviously if you say I can't hear right, so I'm going to say the answer. And natural numbers start with 1, 2, 3, 4 and so on up to infinity. Okay, and whole numbers start with 0, 1, 2, 3 and so on up to positive infinity. Okay, so this is natural numbers, this is whole numbers. This is what we already know. Now the whole of natural numbers, I know it's quite ironic, the entire natural number set would be present inside whole numbers. So whole numbers is actually natural numbers added with 0, right? So every natural number is in fact a whole number. Okay, so that part is true. Now we are moving to the second subdivision, which is every integer is a whole number. Is every integer a whole number? That is false. Why is that false? I'll just explain it to you now. So integers include negative numbers as well. Integers start from minus infinity, minus 1, 0, 1, 2 and up to positive infinity. This is what integers are. Integers start from negative infinity and go all the way up to positive infinity. Everything is included in integers. Just non-fractional numbers, positive and negative, are both integers, right? Now is this, now you can tell that minus 2 is an integer. Minus 2 is a integer, right? Is minus 2 a whole number? No, minus 2 is not a whole number because it's a negative number. It cannot be a whole number. So all integers are not whole numbers. So that statement is false. Now we are moving on to the third subdivision, which is every rational number is a whole number. So rational number is q. Sorry, I'll use the other ink now. Rational number is q, and any number that can be represented in the form of p by q, where q not equal to 0, is a rational number. But for it to be a whole number, it can only be 0 through positive infinity, right? If you say 4 divided by 5 is a rational number because it can be expressed in the form of p by q, where q not equal to 0, but it's definitely not a whole number. So this statement is also false. Every rational number is not whole number. Okay, so that is it for this exercise. I hope you understand these things. These are not that difficult. If you have seen the previous 2 videos, this would be a piece of cake for you. It would be very easy for you, and these are all the questions for this exercise. And if you have any questions, if you have any doubts, please post them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this one. See you in the next video. Bye for now.